Alright, so let's check out the quotient rule for log functions. And that says if you got a log of some base of x divided by y, some kind of quotient, that's equivalent to saying log of that base of x minus the log of that same base of y. And so knowing this relationship can help you simplify problems when you're solving logarithmic equations, for example. So in first I want to show you kind of an example of how this would make sense. Um, so logarithmic and exponential functions are inverses of each other. So um, so for example, here's my kind of model that helps me keep straight of the relationship between exponents and logs. 10 squared is equal to 100, right? Well, that means that log base 10 of 100 is equal to 2. So basically, log is asking the question, what do I have to raise the base to in order to turn it into this? So I have to raise 10 to the power of 2 to turn it into 100. Okay, so let's look at an example of log base 10 of 100 minus log base 10 of 100. So if it's not stated, if I don't say the base, if you're not given the base, the assumption is that the base is 10, the common log. Okay, so for example, this rule is saying that log base 10 of 100 minus log same base 10 of 100 would be equivalent to log of 100 divided by 100, right? Okay. Well, log of 100 divided by 100 is 1, so that'd be log of 1. So base 10, so the question is, what do I have to raise 10 to the power to turn it into a 1? That's 0. Anything to the power of 0 is 1, right? Well, look at this. Log 100 minus the same log, something minus itself is going to equal 0. Okay. I don't know if that helps at all. That's just an illustration of this working. What this has to do with is maybe think of it like this. What's 10 to the third divided by 10 squared? Well, that's equal to 10 to the 3 minus 2, right? Which is equal to 10 to the first, right? So it's very related to the, so this would be equivalent to that, or it would correspond to that. It's very related to the quotient rule for powers, right? So powers and logs are inverse functions of each other. All right. Hopefully that helps. That's the background. Feel free to ignore all that and just memorize log of some base of some quotient. You can split it up so it's the log of the top minus the log of the bottom, right? So let's try some examples. So the quotient rule would say that log of 1 over 100 is equivalent to, and again, there's no base stated here, so we're assuming log base 10. So log of 1 minus log of 100, the denominator in the quotient. So log of 1 would be 0, because it's saying, what do I have to raise 10 to the power to? To what do I have to raise 10? All right, to what power do I have to raise 10 in order to turn it into a 1? Well, if I raise it to the power of 0, it becomes a 1. So 0. Log of 100 would be 2, right? 10 to the power of 2 is 100. So the answer would be negative 2. So I'm going to look at this and say, oh, that looks kind of complicated. Maybe, knee-jerk reaction, grab the calculator. But you can use the quotient rule here and split this up. This is log of 1 minus log of 100. Log of 1 is 0. Log of 100 is 2. So 0 minus 2 is negative 2. Boom. Here's another example. So log base 3 of 3 over x. So this is equivalent to log base 3 of 3 minus log base 3 of x. Log base 3 of 3, in other words, what do I have to raise 3 to the power 2? I struggle with that phrase. To what power do I have to raise this base of 3 to turn it into a 3? Well, just 1. 3 to the power of 1 is 3. So this is 1 minus log base 3 of x. And in turning, that's not enough information to solve for x. But knowing this, I could, maybe this form would be easier to solve than this when I'm solving a logarithmic equation, for example. So look for ways in which, if I've got something in this form, it'd be easier if it's in this form, or if I've got it in this form, it'd be easier to deal with it with that form. Yeah. So that's it, and I wish you all the best. Good luck.